Okay, place those goggles over your eyes, strap in, and don't forget to hold on tight. We're going to see how fast we can really go. Long legs and a tall yet muscular frame, not exactly the norm when compared to the shorter builds of short-distance runners. But the fastest man alive makes it look easy to move that fast. So far, the fastest anyone has run is just over 27 miles per hour, a speed reached briefly by sprinter Usain Bolt at the halfway point of his world record 100-meter dash. And humans can go even faster. The top speed we could reach may come down to how quickly the muscles in our body can move. Our muscles should be able to reach speeds as fast as 40 miles per hour. The reason we can't do it is that we're in the air for too long. Our limbs can only take a certain amount of force when they strike on the ground. That's why on skates, you're able to outpace a runner. Gliding allows for more traction. What would make us a lot faster is simple-ish. Longer legs, really wide hips, or extra legs, like an insect. I'd give running on all fours a try. It would be fun at least. In 2016, speed records weren't just broken on the running track, they were broken on the ski slopes in France. The world record for downhill skiing belongs to an Italian ski instructor and a mountain guide. In 2016, assisted only by gravity, the instructor set a human land speed record of around 158 miles per hour, skiing across the zone near the bottom of a course in just over 2 seconds. Wow, I can barely stand up on skis, let alone move half that fast. The fastest a tiger beetle can sprint is up to 5 miles per hour. Doesn't sound that fast really, but consider this. It's covering 120 of its body lengths in a single second. For comparison, Bolt covers about 6 body lengths per second. To match this beetle, he'd have to run about 480 miles per hour. That's twice as fast as a peregrine falcon. Tiger beetles have extremely sharp eyesight for insects, but while they're running, the world turns into a featureless smudge. This means the beetle has to stop every now and then and see where it's going. So they're pretty fast, but there's a mite, a special mite, whose speed is equivalent to a human running roughly 1,300 miles per hour. At its quickest, this sesame seed-sized mite can move 322 body lengths per second. Wow! Most cats run 0 times their body length for the majority of the day. Yeah. Well, we're not going to be moving that fast anytime soon. We've got a few tricks up our sleeve, thanks to our big brains. We can use technology. Ooh. The fastest we've ever traveled on land over 1 mile is 763 miles per hour. It was done back in 1997 in Nevada in a Thrust SSC. That's a big improvement from the first holder of the record. In 1898, a Frenchman hit the actually pretty amazing speed of 39 miles per hour in his electric-powered car. Through the air, we've traveled at Mach 3.3, that's around 2,100 miles per hour. It's all thanks to the fastest jet aircraft in the world, the Lockheed SR-71 Blackbird. Amazingly, this plane doesn't have a top speed. The only thing limiting its speed is temperature. If it was allowed to fly as fast as it wanted, it would literally melt in midair. On water, the speed record is just over 275 knots, or a little over 317 miles per hour. A jet-powered hydroplane called the Spirit of Australia did it back in 1978. Not bad if you want to get to your favorite fishing spot quickly. In 1896, there weren't that many driving laws. But still, Walter Arnold decided to break one of them and became the first man in history to receive a speeding ticket. The speed limit at the time was 2 miles per hour. You could have walked faster, and most people did. But that was too slow for Arnold, who decided to race through the town at 8 miles per hour. Eventually, he was caught and received a 1 shilling fine. Quite hefty for the time. A man named Felix was taken over 127,000 feet into the edge of space in a balloon that, when fully inflated, was about the size of the Statue of Liberty. Having no choice but to jump out, he eventually reached the fastest freefall speed ever, 843 miles per hour, in a specially designed suit, of course. landing back on solid ground in just over 9 minutes. He became the first person to break the sound barrier in freefall. The fastest speed a human has ever traveled is around 25,000 miles per hour. The crew of Apollo 10 reached this on May 26, 1969. This was also the highest speed ever reached by a manned vehicle. Are you feeling the hankering for speed yet? Good news! The Earth rotates once roughly every 24 hours. Math. This means that the Earth and you are spinning at around 1,000 miles per hour. That's not including how fast we're all moving through space on this giant rock. We're zipping along at 18 miles per second. That's 67,000 miles per hour through the dark vacuum of space. Our Sun and the Milky Way appear to be moving at an average speed of 448,000 miles per hour through space. While that sounds extremely fast, and it is, it'd still take about 230 million years to travel all the way around the Milky Way. So, you're probably moving a lot faster than you thought you were, but there's a good reason you're not a human puddle right now. Speed obviously isn't the issue. The real issue is acceleration. Changes in speed are expressed in g-forces, which just means the acceleration of an object relative to Earth's gravity. If you're sitting on the sofa, you're experiencing 1g. Now, most of us can withstand up to 4 to 6 g's, like on a roller coaster. Some pilots manage up to about 9 g's for a second or two. But sustained g-forces are a big problem. Some pilots wear special high G suits and are trained to flex their torso muscles to keep blood from whooshing out of their heads and into their legs. They can still operate their aircraft properly at about 9 Gs. The record for temporary Gs is an amazing 82.6 Gs. Riding a rocket-powered sled backward in 1958, Eli Beating Jr. hit the brakes and stopped in a tenth of a second as part of testing for space travel. Blacking out but only suffering back bruises, it was a remarkable demonstration of the body's resilience to short bursts of deceleration. More than 100 years ago, a super-famous scientist named Einstein came up with an idea called relativity. There was an experiment that tested this out with 2 clocks set to the exact same time. One clock stayed on Earth, while the other flew on a commercial plane. After the airplane returned from its trip around the world, the 2 clocks were compared. The clock on the fast-moving plane was slightly behind the other one. So yes, time travel is a real thing if you're going faster than another object. Now, another place time slows down is when you're in line at the checkout stand at the supermarket. But hey, it's all relative. The safest place to test high-speed travel is space. It's an empty vacuum after all. But imagine speeding through space. Anything the size of a grain of sand would become a high-speed projectile. The real danger, though, would be small hydrogen atoms just floating around. The hydrogen would shatter into particles that would pass into the ship. It wouldn't be pretty. Your spacecraft would also heat up really quickly, too. Sounds dangerous. You go first. You switch on the light as soon as you enter a room. You never even stop to think about counting how long it takes for the bulb to light up. You couldn't. It's as if it's instant. Well, technically you could if you were fast enough. Good luck clicking that stopwatch in time when you're measuring over 670 million miles per hour. That's 180,000 miles per second. Almost the distance from the Earth to the Moon in the snap of a finger. Oops, wrong sound effect. Can you give me a finger snap? Yeah, that's it. In the snap of a finger. And the Moon's further away than you probably think. If all the planets in the entire solar system were lined up in one epic conga line, they'd fit between the Earth and its satellite. And that's including poor outcasted Pluto. Okay, light is fast. Moving on. It's a beautiful sunny day, perfect for a jog. And like any other day you go for a run, you stop and think, hey, I wonder what the speed of sound is. Don't you? Well, definitely not nearly as fast as light. Need proof? Check for yourself next time it storms in your area. You'll see lightning flash before hearing the crack of thunder. The light from that bolt rushed to you, zoomed into your eyeballs, and up into your brain for you to understand, oh, lightning. All the while, the sound wave from the thunder is still on its merry way to your ear. It'll get there, just give it time. By the way, thunder isn't the sound of storm clouds crashing together. It comes from that very same lightning bolt. It races toward the ground and rips a path through the air as it does. The air politely moves aside to make way for the lightning, and in the instant the lightning's gone, boom! The air comes back together and makes the sound we call thunder. Oh, and here's a fun fact. Sound travels faster underwater than in the air. A little over 4 times faster to be exact. So if you were to go for a swim with your friend and shout something bizarre underwater, they'd hear it a bit sooner than if you did the same thing outside of the pool. Uh-oh, everybody else heard it too. Oops. Sound also travels over longer distances underwater. It's why humpback whale calls can be heard for thousands and thousands of miles. But in a controlled environment where the air is dry and we have a constant temperature of 68 degrees Fahrenheit, the speed of sound is about 760 miles per hour. Now, that's a more realistic number, one that people can even reach. The famous Bell X-1 aircraft was the first to break the sound barrier on October 14, 1947. Test pilot Chuck Yeager was in the cockpit of the rocket plane. Imagine hearing that sonic boom for the first time ever in history. Bravo, Captain! Humans can race with sound, but light is a whole different challenge. For one, measuring it in the first place is no easy task. The official speed of light has changed several times throughout history, even going back to the 1600s. After centuries of debate and experiments with different results, the scientific community finally settled the matter in 1983. Maybe. To measure the speed of anything, you'll need to know 2 things: the distance between point A and B, and the time it takes for an object to travel between those points. With distance divided by time, you'll have yourself the speed of light. But with every experiment done to measure light speed, there's always been an extra cog in the wheel that everyone overlooked, or rather brushed aside. When doing an experiment using light beams and mirrors, we've always included the light beam's trip from A to B and back to A. With equal speed and equal distance, we have ourselves a controlled experiment and conclude an official speed number for the books. Case closed. Let's celebrate! Not so fast. A certain someone in 1905 had something to say about this, and that someone put a theory out there that light can travel different speeds going forward and back. Still can't wrap your head around it? Well, let's take this example. You had a long day. You pulled an all-nighter at work and can't wait to sink into your comfy warm bed. You get on a bus and head home. The night's clear and there's zero traffic on the road. Before the wheels on the bus can even go round and round, you immediately conk out in the back seat. But right before that, you checked the clock and saw it's exactly 10 p.m. What? After a big bump on the road jolts you awake, you become aware of your surroundings. But you suddenly find yourself in the exact same spot as the moment before you fell asleep. That was a quick nap. But then you look at your watch and it's now 11 p.m. You fell asleep in the bus and missed your stop. You'll have to repeat the exact same route all over again. Bummer. What can you determine from this? Since the whole ordeal took you an hour, you can assume it took exactly 30 minutes from the bus stop to reach your house and another half hour from your house back to the bus stop. Sounds logical, right? In our physical bodies, such a conclusion makes perfect sense. But it was Albert Einstein who challenged this idea. With his reasoning, the trip could have taken 59 minutes to get home instead of 30 and 1 minute back to the bus stop. Or even vice versa. Since you were fast asleep, there's no way you can know. And this idea is what's keeping scientists and physicists up all night throughout the decades. When you get into light speed in space, then the mind-blowing stuff starts happening. It takes approximately 8 minutes for light to reach Earth from the Sun. So, light is super slow in space? Not really. Now we're talking unimaginable distances. It takes 8 minutes for our Sun's light to travel over 90 million miles to our planet. That's something to think about when going to the beach. The sunlight that made your tan lines traveled so far across our solar system to reach your skin. Ah, how thoughtful. And you can get sunburnt even on a cloudy day. That's how powerful our star is. Now, imagine yourself living on Pluto. I know, its planet membership got revoked in '06. But hey, call me old school. Our former furthest planet from the sun is so far away, it takes 5.5 hours for sunlight to get there. No wonder it's always cold. The first planet in line is Mercury. The sun's rays reach it in a mere 3 minutes. Hey, that's probably enough time to listen to your favorite song. By the time the song ends, the Mercurian version of you, will be basking in the sun's glory. It'll be impossible to listen to that track in space since sound can't even travel out there. No one can hear you scream. Oops, there she is again. Music is just vibrating air, and without any air in space, sound can't travel. That explains why it's so eerily quiet out there. Okay, can somebody take the scream girl down the hall? And while we're up in space, let's pay our neighbor a little friendly visit. Alpha Centauri is the closest star system to our own. And what fun, the trip is just 4 light-years away. That's 25 trillion miles and 137,000 years on the road. Yeah, don't forget to pack a big lunch. To put all that in perspective, it would take around 5,000 generations in a super shuttle traveling through empty vast space to complete the journey. And we won't be able to come close to the star. Oh, and that's just one way. Okay, I think I'd rather come back to Earth now. Whew, that's better. Now, the longing question: how can we measure the speed of light without that little dilemma about the return trip? Oh, I got it. Why don't we just measure the speed with a super high-tech camera and map it out frame by frame until we're able to write down its speed? Well, nothing's as easy as it seems in the world of physics. Because when filming the light through a lens, we're not seeing the light itself, but rather a reflection of it. We just circled back to square one. Okay, scratch that plan. Then how can we prove light is going the same speed to its destination as its reflection is back to point A? Does the one-way speed have a defined value that's not a constant? Well, this is the ultimate question among scientists, and so far, there's just no way of truly measuring it. Unlike the speed of sound, which is more conceivable, the speed of light might just be light years ahead of us. Yes, just more fun light facts brought to you by The Bright Side. See the tie-in? Okay, never mind. Whoa, something doesn't feel right. Everything seems shaky. It's definitely not an earthquake, and it's actually getting worse. The clouds seem to move quicker than usual, and the animals are going into a frenzy. The news anchor pops up on the TV in an alarmed tone and says, "Good morning. We're sorry to interrupt your program. Scientists have just discovered that the Earth's rotation has been fluctuating at an unusual rate. A group of specialists believe that the Earth is increasing its rotation with every second, and they don't know why." Even if the Earth increased its speed by 1 mile per hour, the day would only get shorter by a minute and a half or so. We wouldn't really feel it, and you could go on like nothing is happening. But as the Earth spins faster, our bodies, which are adjusted to a 24-hour timing, will have a hard time trying to cope with it. If you live by the equator, that means the rotation of the Earth is going quicker than at the North and South Pole. The area by the equator needs more time in order to complete its full rotation from the starting point. You'll experience more rain than usual. The Earth's rotation keeps the weather consistent and balanced so that nothing abnormal happens. But because the Earth is moving so fast, the weather is acting up. We'll start to see more storms and more cozy days inside, sipping on hot cocoa. Even though it seems weird, everyone can go about their day. But if the Earth picked up some speed and moved at 150 feet per second, the day would be reduced to only 22 hours. It kind of makes you feel jet-lagged 24/7. Every business works with the 24 hours a day schedule, so taking away even 2 hours can have catastrophic effects on the world economy. The whole calendar will have to change and adjust to the new timing. Clock designs will change with the new midnight, replaced with 10 o'clock. And with each week, the hours will shorten, so there will be no proper way of telling time except by sunsets and sunrises. The weather will continue to get worse and worse, feeling like the rain will never stop. The animals that rely on weather patterns won't know how to function, and mass migrations will occur from almost all species of animals. Flocks of birds will be flying everywhere and reach places they normally won't go to, affecting the whole food chain and ecology. Woods, jungles, and other places where animals roam are kept in proper balance when unaffected by humans. If it constantly rains in certain areas, then floods will force animals to move to other territories and compete with the predators in the area. If the Earth picked up speed every day, then standing on a scale in the Arctic would tell you weigh 180 pounds, but around the equator you might weigh about 179 pounds. That's because of the extra force opposing gravity in that area. With the Earth spinning faster, all airlines around the world stop, since the radar systems have gone haywire and the weather is too dangerous to fly. Everyone has to get around by car. Satellites are positioned in such a way that it's crucial they remain where they are in order to bounce signals to us. Because of what's happening, Wi-Fi and TV signals can't go through. Communications around the world will end up short and slow, and eventually we'll have a total communication blackout. Ships will cease to operate, and global trading will collapse, adding extra damage to the already failing world economy. Winds will get stronger and faster than usual, which means temperatures will change. Storms like hurricanes will be stronger than ever and have more energy for destruction. And still, at 100 miles per hour, the equator will now be swallowed up in the water. The Amazon basin and small islands will now completely submerge in water by around 50 feet. Most of the plant life will be in danger, especially by the equator. With woods threatened by floods, more animal environments will be in jeopardy. The trees and plants won't survive so much flooding. If the Earth rotated so fast that the hours would now be reduced to 15, then we'd probably feel like we're always on a jet plane going through turbulence. It would be impossible to sleep if the Earth kept picking up speed every second of the day. So days would be around 7 hours long as well as nights. The whole world would be flooded, except for the highest points and the tallest mountains. If that happens, humans will most likely end up there clinging to the last remaining clear patches of land. Most of the animal life will be extinct as well. And as the Earth is spinning faster and faster, the crust will lose its durability, allowing more frequent and stronger earthquakes to happen. Volcanoes will erupt all over, even if they're submerged in water. It'll go on like this for quite a while. Many major natural disasters like earthquakes, tsunamis, volcanoes, and even melting ice sheets have sped up the speed of the Earth by milliseconds. So, with the Earth's continuing speed increasing, these natural disasters will make the planet go even faster. Even if it's just for milliseconds, it's enough to have major consequences. The Earth is now spinning at 1,000 miles per hour. And as you're sitting with the rest of the survivors, you feel yourself levitating slightly. You'll see tiny pebbles and rocks floating inches from the ground. The clouds above you are passing like shooting stars. The air is thick with moisture, since water is rising to the top, forming thick clouds ready to pour. But since gravity is weaker, some of the rain is suspended in the air. Many small objects will be floating around as if you were in space. The days and nights won't be longer than a few hours. At this point, the whole world will be flooded and the crust will be 80% gone. If it goes on any longer, there won't be any living things around, probably except for microscopic creatures that can withstand extreme and harsh conditions. The Earth would need to spin at approximately 17,600 miles per hour to cancel out the gravity for things to start floating around. At this point, all the water in the ocean will rise and look like reverse rain. The large mountain rocks will separate from the bedrock and levitate above the ground, looking like little planets in space. The Earth is now spinning 17 times faster than usual, which makes one full rotation around its axis only 84 minutes instead of 24 hours. If you manage to stay that long, then you'll literally see the days and nights go by in an instant. You'll also be floating aimlessly in the sky, bumping into rocks and other surfaces. You won't recognize anything anymore. The Earth's crust is ripping apart, exposing the magma underneath. So landing on the ground isn't an option. You'll see outer space as you go higher and higher. You won't know how fast you're going, but all you know is that you're probably the only human left in this spinning world. The Earth will eventually spin so fast that the rest of the layers will start to peel off, exposing the Earth's interior. It'll start to squeeze itself from the core until it becomes similar to a pancake. Nothing can survive at this point. So much heat will be produced from the core that the planet will heat up like a microwave. All the water will disappear, and it'll look like a red dot in the solar system. And once it starts to approach the speed of light, time will freeze. The rocks and floating elements won't move and will eventually be distorted. And with enough effort, the Earth will eventually turn into a black hole. Of course, nothing like this will ever happen. According to scientists, Earth will most likely slow down in rotation. Ever since the Moon came into the picture, the Earth has been slowing down by around 4 miles per hour every 10 million years or so. That's because of the Moon's gravitational pull on our little blue planet. It'll most likely go on that way. So hey, what's your hurry?